Okay, we have 6.3, or sorry, 6.4, and we are on our examples here with factoring, and we're going to try to factor by grouping is what we're going to try to do here. When you're factoring by grouping, okay, it's actually the concept of exactly what you're saying is what you want to do. You actually want to group the items together. So what I'm going to do is I'm going to take these two right here. And since there's 4 items, that's normally a key that you could try to factor by grouping. So I'm going to group the first 2 and the last 2, and I realize in these that there is a 4 that I can divide out of both of them. So I take a 4 out of them, right? And I also realize that I have an x squared that I can take out of both of them, leaving just an x right there. So I can actually take an x and squared out of both of those terms. All that's left in this one is because I divide that by 4, that's gone. So I have an x left over here. I divided that by 4, so 8 divided by 4 is 2, and I took an x squared out of both those, so all I have left is x minus 2, and that. And you can double check your work. 4 times 1 is 4, x squared times x is x cubed, 4 times 2 is, or negative 2 is negative 8, and the x squared comes along for the ride. Now up here, they both have a 3 that I can take out of them, so let's take a 3 out of both of them. And, sorry here, got too close. Let's take that out, but when you divide the 3 out of both of those, right? When you take that 3 out of both the items, that goes out here and it's a positive 3. There's no more 3 there, and 6 divided by 3 gives you a 2. So really all I have left in there is an x, because I still have that x there, right? And a minus 2. Now here's how I know I did this right. Whenever you factor by grouping, here's what you need. The first and the last term, see that? They need to be the same here. These two terms in parentheses need to be the same. And if they are, then you know you factored by grouping correctly. So we're going to drop that down, and we're going to drop that down right there. And we end up with a 4x squared plus 3 because we combined our like terms there. And the x minus 2 and the x minus 2 come together, and we end up getting x minus 2 as well. So when we factor this, we get 4x squared plus 3 times x minus 2. We've already done some examples like this, but just so you can see one again quick, I can rewrite this as x squared squared minus 13x squared plus 36. And the reason that I'm doing that is right now this might be hard to see, but if I substitute an x squared out and I make that a, everywhere there's an x squared I put an a. That's an a squared. That's a 13a. And that's a 36. So the point is, now this looks like something we could factor. And can you think of two numbers that multiply to give you 36 that add to give you negative 16? Well, I can. Negative 4 and negative 9. So negative 4 and negative 9, because negative 4 times negative 9 is positive 36. Negative 4 plus negative 9 is negative 13. So when you factor it, you end up getting a minus 4. That's what we have there. And you end up getting a minus 9. Okay, so no problems. This is what we're looking at, except, just keep that in mind, we have a minus 4 and a minus 9. Okay, but here's the problem. We had a minus 4, and we had a minus 9. Now we aren't done, because right up here it says that we have x squared equals a. So I got to substitute x squared back in. So I got x squared minus 4. Right? So I got x squared minus 4, and I get x squared minus 9. When I look at both those, I actually see the difference of squares, right? Because this is a squared term, but I can rewrite a 4 as 2 squared. I can even rewrite a 9 as 3 squared. This is even a difference of squares, which means I can write this first term as x minus 2, right? And x plus 2. But I can also write this one, because that's a difference of squares. I can write that as x minus 3 and x plus 3 to get my answer. And there is that completely factored. Okay, that one's just like what we just did. Here's another factoring by grouping one. So just so you can see some more factoring by grouping, let's group those two items together and those two. And when I group them together, there's no number that can come out, but in both of these I can take an x squared out, leaving me with just an x in the first one. So if I take an x squared out, I end up with 2x left over on the inside, a 2 and an x, and a minus 3. And in this one, I can take a 2 out of both of those, right? So if I take a 2 out of both of those, it's a positive 2 coming out, so I end up with 2x minus 3. So since those are both the same, I know I factored by grouping correctly. So I can take that and get x squared and take that right there and get plus 2. So x squared plus 2. And the last term comes along for the ride. We get 2x minus 3. And there is my terms factored completely. Other than that, the reason why you want to do all this stuff is to solve and set it equal to 0. So if they were set equal to 0, I could solve each of these now by literally setting each of them equal to 0. So basically, we're going to stop there, and if you have any other further questions or need any other examples on 6.4 with factoring, please let me know.